We're going to spend the next few videos discussing lines, investigating lines, parallel lines, perpendicular lines, intersection of lines, that sort of thing. I want to start off with this one right here, this first problem here, where we have, we're given that angle 5 and 6 are a linear pair. So if you look over here, and I guess I should label this other point maybe angle 8. Okay. So we have these two lines intersecting, and you can see clearly that angle 5 and 6 are a linear pair. 6 and 7, that's also a linear pair. And remember, linear pairs, they share one side in common, and the other side of each angle is an opposite ray. So, and you can see that here. You've got an opposite ray. This ray and this ray are opposite ray, and here is a shared side. Now, the thing is, we know that linear pairs are supplementary. So we know that angle 5 and angle 6, they add up to 180 if you look at the measure. Now, what we want to do is we want to prove that angle 5 is congruent to angle 7. In other words, the measure of angle 5 is equal to the measure of angle 7. Now, what we have here, notice that this right here, this angle, and this angle, I'll put a note there. We're going to prove that those are equal. And these are vertical angles. And what we're really doing is proving that vertical angles are going to be equal. The measure of the vertical angles are going to be equal. So let's see how we would start off with something like this. Now, there are different methods of proof. There are different structures to proofs. I'm just using these two-column proofs where we have a statement and we have a reason. And what I don't want to do, I don't want to get too bogged down in names and like names of theorems, names of postulates. As much as possible, I'd like for us just to be able to state the reason. I mean, if you don't get the name of the postulate or the name of the reason correct, as long as you describe why what you wrote is true. Let me illustrate here. So first of all, we write, I'm going to start and I'll write angle 5 and angle 6 are a linear pair. Okay, so I write that first of all. Pair. Angle 6 and angle 7 are a linear pair. Okay? And the reason I know that is because it was given. So I'm just going to write that as given. Now, here's the next thing. We would say, okay, the measure of angle 5 plus the measure of angle 6 is equal to 180. Okay? Because linear pairs are supplementary. Are supplementary. And I could also say the measure of angle 6 plus the measure of angle 7 is equal to 180. Okay? Same thing, same reason. Okay? So we've got these things. Now, if that's true, notice what we've got here. Angle 5 plus angle 6 is 180. And angle 7 plus angle 6 is 180. Well, then that must mean that the measure of angle 5 is equal to the measure of angle 7. In other words, we've shown that angle 5 is congruent to angle 7. And why? Because, think about this, angles supplementary to the same angle are are equal. Okay? Okay? Angles supplementary to the same angle are congruent. Yeah. Right? Because, I mean, that makes good sense, right? Angles supplementary to the same angle are congruent. Now, I guess we could call that congruent supplements theorem, okay? But the thing is, remember that reason is why that works. Okay, so now, so look, what we found is angle 7 is congruent to angle 5. Now, while we're at it, we could say, well, by the same proof, we could say angle 8 is congruent to angle 6. Yeah. So you see here that these vertical angles are congruent. Okay. Yeah. Now, so let's go on. So we're going to be talking about lines and that sort of thing. Now, when it comes to these proofs, you have to be patient with yourself and just realize, okay, sometimes it takes a while to get the flow of this and how these work. So it just requires patience. And what you don't want to do is get so bogged down in the correct terminology that you just get stuck and can't proceed. So you just go through and make sure you can explain why you're doing what you're doing. Okay. Now, just some terminology here. We talk about two lines being parallel if they are on the same plane and do not intersect. So that's the way we're going to think of parallel lines. Lines that do not intersect and are not on the same plane are called skew lines. Okay? Two planes that do not intersect are called parallel lines. Parallel planes. Two planes that do not intersect are called parallel planes. And I have these, I put a little diagram here for you, or a little picture. Now, there's a couple of postulates I want to just... The thing about geometry is there's a lot of these postulates and theorems, and what you want to, for the long term, what you want to do is just understand why these things are true. Just understand why they're true. There's this parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the line. Okay? So that makes good sense. Okay? So you've got this line and you've got a point, and you're wondering, how many lines are there that will pass through this point that are parallel to this line? Well, obviously just one, right? Now, down here it's a perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So you have a point up here, and you have a line down here, and you want to draw perpendicular to this line. Well, there's only one that's going to pass through that point. You can't go any place else on this line and still get a perpendicular to that point. Okay? So that's the nature of things in geometry. You have these formal statements that seem intuitive. Now, let's look at some theorems. Here we have, and these are theorems relating to perpendicular lines. Okay? Perpendicular lines. And you notice the perpendicular because they've got that little symbol here. Okay? Now, if two lines intersect to form a linear pair, okay, and look at G and H, that's exactly what happened. Two lines intersected to form a linear pair. Okay? Not just a linear pair, but of congruent angles. Okay? Now, there's lots of ways these lines could intersect to form a linear pair. There's one way. Okay? You've got a line, here's another line, they intersect. But in particular, these have congruent angles. So these angles right here are congruent. Then the lines are perpendicular. If that happens, if that linear pair formed gives you congruent angles, then you know that those angles are 90 degrees. Those lines are perpendicular. Okay, theorem 2. If two sides of two adjacent acute angles are perpendicular, then the angles then the angles are complementary. So that's pretty obvious. Notice this angle plus this angle, those are going to add up to 90. Okay? If two lines are perpendicular, then they intersect to form four right angles. Once again, pretty obvious, right? If you have two perpendicular lines, their intersection, you're going to have four right angles. Now, so these are theorems, and sometimes we're asked to prove theorems. Postulates we're just given. Say, okay, here's the postulates, use these. No need to prove them. But here we want to prove this theorem 3.1. So let's see how we would do that. Okay, so let's see if we can draw a little diagram. Okay, so I'll draw a diagram here. Here is a line. Here's another line. And I'm going to say this over here. I'm going to say this over here is angle 1. And this here is angle 2. Okay. So I'll call this H and this G. Okay. So we've got this line. These two lines intersect. Okay. Now, let's see, this theorem calls for these two angles to be equal. So I'm going to say, let's suppose the measure of angle, let's suppose 1 is congruent to 2. Okay. And let's say angle 1 and angle 2 are linear paired. Okay. Or a linear pair. Now, if two lines intersect to form a linear pair of congruent angles, then the angles are perpendicular. Yes. So this is the situation. We've created the situation down here that's set up in that theorem 3.1. Now, this right here is what's given. And what we want to do is we want to prove that line H is perpendicular to line G. That's what we're asked to prove. Okay, so let's see how we would proceed. First of all, okay, I've got my statement. And I've got my reason over here. Now remember, this is not the only way you can prove. You can use different structures of your proof, but I'm just getting us used to this. Okay, now first of all, I want to state this. I'm going to say angle 1 is congruent to angle 2, and angle 1 and angle 2 are linear pair. Are a linear pair. Now, that's what we do first. We put down what's been given. Now, the next thing, okay, so what can we conclude from that? Well, we think about, okay, what do we know about linear pairs? Well, the measure of angle 1 plus the measure of angle 2 is equal to 180. This is something we know. Okay? Because linear pairs are supplemental, are supplementary. Supplementary. Now, we could have put in an intermediate step in there and said angle 1 and angle 2 are supplementary because linear pairs are supplementary, and then we could say the measure of angle 1 plus the measure of angle 2 is 180 because the definition of supplementary. But I just kind of skipped that step. In other words, I went right and said, well, the measure is equal to 180. Okay, now, let's see what we can do next. Okay, let's think about what else we can use from our given. Our given tells us that angle 1 is congruent to angle 2. Well, that means that the measure of angle 1 plus the measure of angle 1 is equal to 180. I just did a substitution. substitution. Okay. Well, what does that mean? That means that 2 times the measure of angle 1 is equal to 180. Okay. So that's just, adding like terms, right? Okay, so I'm just going to say adding like terms. There we go. Another thing you could say instead of adding like terms, you could say distributive property. Yeah, you could say that. But I think adding like terms is a little more direct and says exactly what we know that in algebra. We can always just add like things. Therefore, the next thing is the measure of angle 1 is equal to 90 degrees. And that's just the division property of equality. So I'll just say the division property of equality. Okay, division property of equality. Well, that means that the measure of angle 2 is equal to 90. Okay. Although we don't even really need that there. What we've got is this. Since the measure of angle 1 is equal to 90, angle 1 is a right angle. Okay. That's just definition of right angle. Thus, G is perpendicular to H. And that's just definition of perpendicular lines. Because if 2 lines intersect at a right angle, that's how we define perpendicular. Okay. Okay, now I said it, I talked a lot there, but down here on your assignment, notice you've just got some straightforward calculations to do involving perpendicular lines. I've got a proof down here for you, and then another proof. Looks like about 3 proofs. So there you go. And be sure and ask questions if you need.